Very good morning, all plus one class students. Students, today we will start our main topic that is of unit number one, chapter number one, fundamental forces in nature. Fundamental forces in nature. Actually, students, in a nature there are main four forces that all called fundamental forces in nature and are gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. That are the four forces that we have discussed. In this topic we will discuss about the definition of that forces. Next one we will discuss examples of that forces where they actually exist, and last one the important properties of that forces. Now first of all we will discuss with the help of one paper, one flow chart. Now this is the fundamental force in nature. There are four forces. One is gravitation, second electromagnetic force, third one is strong nuclear force, last one is a weak nuclear force. All are the four forces. It is noted by Fg, this is Fe, Fs and Fw. Fg ratio Fw ratio Fe Fs is equal to 1 ratio 10 raised to power 25 ratio 10 to power 26 ratio 10 to power 38. It means this expression gives the one relation that the gravitational force, weak nuclear force and electromagnetic force and strong nuclear force, there is a one relation. What is that? That is strongest force in a nature is strong nuclear force. Then next one is electromagnetic, next one is weak nuclear force and last one is gravitational force. It is gravitational force. Now first of all we have discussed about gravitation and electromagnetic turn by turn. Actually students, the basic difference between that two is only related to body. This is the gravitational force is the force between two bodies of masses. It is the force of attraction between two charges. It is a force between two charged body. This is the force between two bodies. Only difference is related to charges. This is related to only body of having masses. Now turn by turn we have discussed gravitational force. Already we have discussed this one in a 9th standard chapter gravitation, Newton's law of gravitation. What is gravitational force? It is a force of mutual attraction between two bodies by virtue of their masses. That is the force of attraction between two bodies in the universe is called gravitation force. Now let us suppose there are two bodies m1 and m2 of masses m1 m2 lies at a point a and b, distance between them r. So therefore F is the one force which is force of attraction. It means a attract b and b attract a. That is m1 mass attract m2, m2 attract m1 with the equal force, and that force is given by F equal to g m1 m2 upon r square. From where this expression become, already we discussed in a 9th standard, and in gravitation unit we will discuss there. So, but actually what is the Newton law of gravitation? According to this law, every body in this universe attract every other body with a force which is directly proportional to product of their masses and inversely proportional to square of the distance between that two. That's why F equal to g m1 m2 upon r square. This is the expression for gravitation force. It means the force of attraction between two bodies is given by F. This is a mathematical expression. F equal to g m1 m2 upon r square. Here F is inversely proportional to r square. F is inversely proportional to r square. Where g is a universal gravitation constant and g equal to capital G 6.67 10 to the power minus 11 Newton meter square kg minus 2. Now next one is electromagnetic force. This is the force between two charges. Let's suppose Q1 Q2 are two charges. Distance between same r and F is the force, but the two charges may be similar charges, either positive either negative or maybe one positive and negative. That's why this force is attractive as well as repulsive, but gravitation is only attractive. That's why what is the electromagnetic force? The force of attraction or repulsion between two electric charges at rest. The force of attraction or repulsion between two electric charges at rest is called electrostatic force. Clear? It is given by in Coulomb's law. Actually, briefly we will discuss that topic in the class +2 in first unit. Coulomb's law there. So according to Coulomb's law, the force of attraction or repulsion between two charged body, that is Q1, Q2, separated by a certain distance r, is directly proportional to product of their magnitude of the two charges. ग्रेविटेशन में क्या था? प्रोडक्ट ऑफ मैग्नीट्यूड, प्रोडक्ट ऑफ द मासेस, यहाँ आ गया चार्जेस, प्रोडक्ट ऑफ द मैग्नीट्यूड ऑफ द चार्जेस एंड इनवर्सली प्रोपोर्शनल स्क्वायर ऑफ द डिस्टेंस बिटवीन देम. वहाँ पे भी यही था, बट यहाँ पे क्या है? इनवर्सली प्रोपोर्शनल स्क्वायर ऑफ द डिस्टेंस बिटवीन देम. यहाँ पे भी वही है. देयरफॉर एफ इक्वल टू प्रोपोर्शनल मैग्नीट्यूड Q1 Q2 अपॉन आर स्क्वायर. इफ द नेगेटिव चार्ज वो भी पॉजिटिव हो जाएगा. तो एफ इक्वल टू के Q1 Q2 अपॉन आर स्क्वायर. तो देयरफॉर एफ इक्वल, व्हाट इज के? के इज इलेक्ट्रोस्टैटिक फोर्स कांस्टेंट एंड इट्स वैल्यू इज 1/4πε0. We will discuss that one in a +2 standard. K, electrostatic force constant, K 9 into the value of K 9 into 10⁹ Newton meter square Coulomb inverse square. Epsilon naught, permittivity of the free space. What is epsilon naught? Permittivity of the free space, and its value is 8.854 10⁻⁻12 Coulomb square Newton inverse meter inverse square. This is all about electrostatic force. That is expression for electromagnetic force. F equal K Q1 Q2 upon R square. This is the expression for gravitation force. F G1 G M1 M2 upon R square. Next one examples. Now, for example, for gravitation, all body falls because of gravitation force of attraction exerted on them by Earth. It means Earth attract every other body towards its center. Why? Due to gravitation force. That's one example. The motion of the moon or an artificial satellite around the Earth is due to gravitation force, etc. It means where the gravitation force exists, some examples there where the gravitation force is exact. That all are clear. That all about. Similarly, for electrostatic force or electromagnetic force, example, force of friction. Force of friction is the one example. Elastic force in a spring. When a spring is compressed or elongated, it exerts a force of elasticity due to net repulsion or attraction between its neighboring atoms, van der Waals force, etc. All are the example of electrostatic force. Clear हो गया? Electrostatic force. Now next one is a property. Number 1, it is attractive. Gravitation force is attractive, but electromagnetic force, it may be attractive or repulsive, because it is a force between two charged bodies. That's why it is attractive or repulsive. What? It is only attractive. Next one, it is directly proportional to the product of the masses of two body. What? Electromagnetic force, it is proportional to the product of the magnitude of the two charges. Product of the magnitude, directly proportional to product of magnitude of two charges. Next one, it obeys inverse square law. Electromagnetic force also obeys inverse square law. Next one, it is central force. Electromagnetic force is also central force. Electromagnetic force is also, it obeys inverse square law. It is a central force. Next one, fifth one, it is a long range force. Electric charge also long range force. Next one, it is the weakest force in nature. Next one, it is a conservative. Conservative means the force is not dependent upon the path followed. It is independent of the path. That is a conservative. It is conservative force. It means if there are two body A and B, but there are third body is C in between that, so that's why it is not depend upon the presence of C. It is the force between A and B remains same. That is path independent. Similarly, electromagnetic force, it is also the conservative force. But there is a one major difference. From gravitational force, electromagnetic force is 10⁻36 times stronger than gravitational force. 10⁻36 times. This is all about electromagnetic and gravitational force. What are the definitions, what are the examples, and what are property, important one. Hope you understand. Thank you.